In this video, we're graphing one more hyperbola. This hyperbola is in general form. You'll notice it's not in our standard form where we see parentheses and we're equal to 1. So we're going to need to complete the square to transform this from general form into standard form. Let's start by getting organized. Let's get our x's together, our y's together, and then our constant on the other side of the equation. We know when completing the square, our leading coefficient has to be 1, but because x squared and y squared have different leading coefficients, we can't just divide to create that leading coefficient of 1. We're going to have to factor to create that leading coefficient of 1. So let's start with the x's. We're going to factor a 4 out, leaving us with x squared minus 4x. And then I'm going to leave a little space here so I have room for my b divided by 2 squared. Now I'm going to continue with the factoring portion with the y. Notice that the leading coefficient on y squared is -9, so we are in fact factoring out a -9. This is going to leave us with y squared minus 6y. Make sure you're factoring out that negative. Okay, let's create some perfect square trinomials. Starting with the x, we're going to take its b value, divide it by 2, and square it. So it's -4 divided by 2 squared. -2 squared is 4. So let's add 4 here to create our perfect square trinomial. But when adding the constant to the right-hand side, remember that we actually have to distribute that 4 that we factored out in before adding it to the other side. So we're going to be adding 16 to the right side. Factoring this perfect square trinomial we just created, we get 4 times x minus 2 squared. Now let's create our perfect y trinomial. I'm going to take its b value, which is -6, divide it by 2 and square it. So it's -3 squared is 9. We're going to add 9 in our parentheses to create our perfect square trinomial. But when adding it to the right-hand side, we now have to distribute this -9 to the 9. So make sure you're taking the negative with you as well. We're actually going to be adding a -81 to the right-hand side. Factoring this perfect square trinomial we just created, we're going to have y minus 3 squared, and adding up our constants, we get 36. The last thing we need to do to transform this to our standard form, remember we need to be equal to 1. So now we'll divide each term by 36 and simplify. We get x minus 2 squared over 9 minus y minus 3 squared over 4 equals 1. Now that we've transformed it into standard form, we can graph it. The first thing I notice about this is that x is first, so that tells me that my hyperbola opens in the x direction, so this is going to be a horizontal one. Let's identify the center. Remember that h is always with x and k is always with y, and we're taking opposite signs. So we have a center of 2, 3. I'm going to start graphing now, so we'll plot our center, 2, 3. From here, we want to create our rectangle, and we're going to use the square roots of 9 and 4 to create our rectangle. So the square root of 9 is 3. 3 is under the x, so we're going to build our rectangle by going 3 to the left and 3 to the right. Then we take the square root of the number under the y to know how far from the center we go in the y direction. Square root of 4 is 2. So we're going up 2 and down 2. And then we draw in our rectangle. We obtain our asymptotes by extending the diagonals of this rectangle. And now we can draw in the branches of our hyperbola. We already noted that it's going to open in the x direction. We know that the branches tend towards the asymptote and the vertices are right where it hits our rectangle. So there we are, hyperbola in blue. Now let's answer the rest of our questions. So we want to identify our vertices. Just look at our graph for those. Our vertices are happening at -1, 3 and 5, 3. To identify our foci, we need to find our c value. C squared is equal to a squared plus b squared. And a squared and b squared were 9 and 4. We get c to be the square root of 13. Since our hyperbola branches are opening in the x direction, we're going to be adding that c value to the x coordinates of our center. Our foci are located at 2 plus or minus the square root of 13, comma 3. Lastly, with the hyperbolas, we need to find the asymptotes. Starting with our positive asymptote, I'm going to check out the slope just by counting. From the center to the corner of the box here, we're going up 2 and to the right 3, so that tells us we have a slope of positive 2/3. And then I'm going to use the center point to write the equation of my line. That's happening at 2, 3. Y minus 3 equals 2/3 times x minus 2. So y minus 3 equals 2/3 x minus 4/3. And then we'll add 3 to both sides. The equation of our first asymptote is y equals 2/3 x plus 5/3. Now it's time to find the equation of our second asymptote, the one going down. Remember that the slope of your second asymptote is always just the opposite of your first one. We can count to double check. Notice we're going down 2 and to the right 3. So here we have a slope of -2/3. And again, I'm going to use the center to write the equation of this line. Y minus 3 equals -2/3 times x minus 2. Y minus 3 equals -2/3 x plus 4/3. And then we add 3 to both sides. Our second asymptote equation is y equals -2/3 x plus 13/3. Frequently what I'll do with these, just to kind of double check myself, because sometimes we make mistakes, is I always kind of just look at the y-intercept and make sure that it hits kind of where it looks like on my graph. So this one here that I have highlighted in green, the Y-intercept is 13/3, so that's just a little bit over 4. So I kind of just look at my graph and say, okay, is that asymptote hitting the y-axis a little bit over 4? Yeah. So then I feel extra confident about the equations of my asymptotes.